Hello. Today we're going to be looking at Chapter 19, the second lecture within Chapter 19, Learning Objectives 3 and 4. So we're going to be calculating standard free energies from free energy formation values, and then we're going to look at how temperature is going to affect spontaneity if we have enthalpy and entropy changes. Okay, so first, our delta G of reaction looks just like our delta S of reaction. So we're going to find it the same way we did for the other. So our delta G naught of reaction will be equal to our delta G of our products minus the delta G naught of our reactants. So we can use a table to find the same thing that we've already done. So in your table, you'll find, in the table that I gave you guys, you'll find delta H naught, delta S naught, delta G naught, and all of those will be used in order to figure out these values. So you don't need to remember these. So if we have the following reaction, it's going to be the same exact thing as for delta S, where we're going to do our stoichiometric coefficient times by our delta G of the substance, right? So very easy to solve for these. We take our products minus our reactants, A delta G naught big A plus B delta G naught big B. So pretty easy to find. We're going to base all of these on, these values are going to be specifically delta G of formation values, just like the delta H of formation values are in there as well. So it is, delta G naught of formation is the free energy change for the formation of 1 mole of that substance under standard conditions. We call this free energy. Okay, so looks very similar to delta H of formation. So like delta H of formation, anything in its elemental state has a delta G naught of 0. So there is no energy required to make it. So there we go. Let's see if we can use the idea of delta G naught. So we have our delta G naught for the following reaction. 2 SO2 gas plus O2 gas goes to 2 SO3 gas. Our delta G of formation of SO2 is negative 300.4 kilojoules per mole, and our delta GF of formation of SO3 is negative 370.4 kilojoules per mole. So our delta G for this reaction is going to be our products minus our reactants. So here we're going to have 2 moles times by our negative 370.4 kilojoules per mole for our 2SO3 product. And that's going to be minus our reactant, 2 mole times by negative 300.4 kilojoules per mole. And then we don't have anything for SO2 because it is elemental, so what we solve for this, we get a delta G naught of our reaction equal to negative 140 kilojoules. Okay, let's look at the reaction where we have a delta H naught equal to negative 35.4 kilojoules. And we have a delta S naught of negative 85.5 joules per Kelvin. I'm going to go ahead. First thing you should always do is convert into the same units. So I'm going to convert this into joules. Okay, so now I have everything in the same unit. So now I'm going to check, okay, we want to calculate the delta G for the reaction at 298 Kelvin. So we have delta G naught of our reaction is equal to delta H naught of our reaction minus T delta S naught of our reaction. So it just gives free energy in the standard state. So it's equal to negative 35400 joules minus our temperature, 298 Kelvin, times by our delta S, negative 85.5 joules per Kelvin. We'll cancel out our kelvins, be left with joules, and we get a delta G naught of reaction equal to negative 9,921 joules, or negative 9.92 kilojoules, which is negative, so yes, this is spontaneous. At this particular temperature. However, notice we have a negative value for our delta S, which means that if we are at high temperatures, if we get too high enough of a temperature, we're going to have a reaction that is non-spontaneous. And we can figure out what temperature that is by actually taking our delta G and setting it equal to 0 and solving for temperature. So we could take, okay, 0 is equal to our delta H of reaction, negative 35,400 joules, minus our temperature, which is what we're solving for, times by negative 85.5 joules per Kelvin. And when we solve this out, at a temperature equal to 414 Kelvin, we have a 0 delta G. So any temperature above that, we're going to have a non-spontaneous reaction. Any temperature below that will have a spontaneous reaction. Okay, that's everything for this video.